Hi there. My name is Dimitris Charalambidis. I'm an IB mathematics teacher, and in this video, we will work together one of the tests I assigned in one of my IB classes. And let's say some things about this test. This test is based on transformation of functions, on modeling with exponential and logarithmic functions, and partially on midpoint and distance formula. It was assigned to an analysis and approaches class, and the exercises are not that much of an IB build-up way created, but they are more direct. Let's move to the first one. Describe a series of transformations occurred to transform f of x to g of x on each of the following cases. In A, we want to go from f of x equals x squared plus 5x plus 6 to g of x equals 2x squared plus 10x plus 12. So basically, we want to go from one quadratic to another. The first thing in this case is for us to see if the one quadratic is a direct multiple of the other. For example, here, we do notice that if we multiply f of x by 2, then that's how we get g of x. By recognizing that, we can easily say that actually g of x is a vertical dilation of factor of 2 of f of x. In B, we want to go from e to the power of x to 3 times e to the power of x plus 1 minus 6. We always describe transformations, the series of transformations, starting from the one which is closer to x. Here, the one that is closer to x is the one in the exponent, the x plus 1. From e to x to go to e to the power of x plus 1, we simply have to do a horizontal translation of one unit to the left. Remember that all horizontal translations are lined. Then we should multiply that by 3. And that means vertical dilation of factor of 3. And then we should subtract 6. And that means that we have a vertical translation of 6 units downwards. In C, we have another transformation from a quadratic to another, but this time we see that none of the two quadratics is a multiple of the other. So here we should follow our main hint, which is we should turn each quadratic to its vertex form and then compare each one of these quadratics separately to x squared. Remember that in order to find the vertex form, there are two ways. We can do it by completing the squares, which sometimes it can be tricky, or we can do it by finding the coordinates of the vertex by applying the formulas minus b over 2a and minus d over 4a, and then plug these numbers into the vertex form, which is the form a times x minus h, which is the x coordinate, in our case, the minus b over 2a, and all that squared, plus k, which is in this case is the minus d over 4a. Here, for the first one, for the x squared plus 5x plus 6, we do see that a is equal to 1, b equals 5, and c is equal to 6. By calculating the discriminant, we get that this is equal to 1, and therefore the coordinates of the vertex should be equal to minus 5 over 2 and minus 1 over 4, which means that the vertex form of the first one is the form x plus 5 over 2 squared minus 1/4. We follow the exact same process for the second one, and we get that this can be written in the form x plus 7 over 2 squared minus 81 over 4. So now, instead of going from f of x to g of x using their standard forms, we will go from f of x to g of x, but this time we will do that through their vertex forms. So I am on the form x plus 5 over 2 squared minus 1 over 4. And I want to find a series of transformations that will take this to the x squared. At first, I should get rid of minus 1 over 4, which means that to do that, I have to add 1/4. And by adding, this means vertical translation of 1/4 units upwards. Theoretically, we are now at x plus 5 over 2 squared. We need to get rid of 5 over 2. So internally, in the output, so that it should be a horizontal translation, I should take out 5 over 2. By taking out, this means that I'm moving to the right. So this is a horizontal translation of 5 over 2 units to the right. We are now at x squared, and we must build up x plus 7 over 2 squared minus 81 over 4, which means that at first I should add internally 7 over 2. We can do that by doing a horizontal translation of 7 over 2 units to the left. Then we should take out 81 over 4 from the whole function, which means a vertical translation of 81 over 4 units downwards. Let's go in D. From f of x, which is equal to 1 over x, we want to go to the rational function 2x plus 5 over x minus 6. The only way for that to happen is if we somehow manage to write the rational function into the form a plus b over x minus 6. To do that, we should get rid of the x's from the numerator. This will happen if somehow we make it and we create a multiple of the denominator in the place of the numerator. Now look at the denominators. It's x minus 6. Its multiples should be x minus 6, 2x minus 12, 3x minus 18, and so on. Here, we will create, we will create 2x minus 12 because we already have 2x. So, I am subtracting minus 12, but I just subtracted it. So, I have to immediately add it, which means that I will be writing 2x minus 12 plus 5, which is equal to 2 times x minus 6, I use common factor, plus 17 over x minus 6, and then we break this fraction into two parts, and we would get 2 plus 17 over x minus 6. And now, it should be quite obvious that in order to go from 1 over x to what we need, in step-by-step way, at first, we will do a horizontal translation of 6 units to the right, and this will create 1 over x minus 6. Then we should multiply, so we should vertically dilate by a factor of 17, and we will get 17 over x minus 6, and then we will add 2 to all that, which means a vertical translation of 2 units upwards. In E, we want to go this time from a rational function to another rational function. The method here is quite the same as before, but this time it's like mostly like from a quadratic to a quadratic. We would have, in that case, we had to bring both in vertex forms and compare them. Let's say convert them. We had to compare them with the x squared. Here we will have to bring both of these into. We should break them into partial fraction. That's how it's called. And we should compare each one of them separately to 1 over x. 2x plus 3 over x plus 2 is finally written in the form 2 minus 1 over x plus 2. 5x minus 3 over x minus 2 is written as 5 plus 7 over x minus 2. I want to see what I can do to go from 2 minus 1 over x plus 2 to 1 over x. At first, let's get rid of the 2. So we should take out 2, which means vertical translation 2 units downwards. That leaves me with minus 1 over x plus 2. Then I should find a way to get rid of the minus, to turn it into plus. This will be a reflection to the x-axis. And from there, from 1 over x plus 2, I want to go to 1 over x. That can be done by a horizontal translation of 2 units to the right. Now we are at 1 over x, and I want to slowly create 5 plus 7 over x minus 2. I will create, first of all, the 1 over x minus 2. And to do that, I should take out 2, which means a horizontal translation of 2 units to the right. We are now at 1 over x minus 2. We are now at here. Let's create 7 over x minus 2. For that to happen, we should multiply by 7 the entire thing, and that should be described as a vertical dilation of factor of 7. And finally, we need to add 5 to the entire function, which is obviously a vertical translation of 5 units upwards. Let's go to f, which is the demanding one, which, to be honest, you only solve it only when you have worked with that kind of questions. Let's see it. From f of x equals x cubed plus 2x squared plus 5x minus 6, we should go to g of x equals minus 8x cubed plus 8x cubed, 8x squared minus 10x plus 6. Here we can see that it's not one of the typical transformations. It's not about just adding or subtracting internally to the whole output or multiplying or dividing. But it looks like, notice that f of minus 2x, which means go in f of x and instead of x put minus 2x. If we do that, we would create minus 8x cubed plus 8x squared minus 10x minus 6, but regarding the variable parts, we would be okay. Which means that up to this point, it can be described as a horizontal dilation of factor of 1 over 2, which is followed by reflection to y-axis. Now, what can we do to go from minus 6 to 6? We can simply add 12. And therefore, after this horizontal dilation and the reflection to the y-axis, a vertical translation of 12 units upwards should follow. Let us now move on exercise 2, which is focused actually on exponential and logarithmic functions. In 2020, President V decided to release bunnies in the school campus to align it with the environment. It was later found that the population P of bunnies with regards to the months after their first release is modeled by the function P of t equals 25 times log base 2 of 32 plus t. In A, we ask students to find the vertical asymptote of f. We know that in order to find the vertical asymptote of a logarithmic function, we should simply take the argument and make that equal to 0. So 32 plus t equals 0, which means that t is equal to minus 32, which is the vertical asymptote we wanted to find. B, find the initial population of bunnies released. Initial stands for the very, very first. So for t equals 0, p of 0 should be equal to 25 times log base 2 of 32 plus 0, which is equal to 25 times log base 2 of 32, which is equal to 25 times 5 equals 125. Unfortunately, after 2 years and 8 months, the population started decreasing by 3% per month. It was found that it would now be modeled by the function g of t equals a times r to the power of t plus 20. Decide on what should the value of t in function g represent. Here, a common mistake students tend to do was that they simply said t stands for months. They are partially correct, but they should specify that t represents the months passed after the population of bunnies started decreasing, not the months after 2020. So the correct answer here, the correct approach would be that t should represent the months passed after the population of bunnies started decreasing. calculate the value of A. Here is another tricky part. Well, let's see what happened. The population at first was being modeled by the logarithmic function, P equals 25 log 2, 32 plus t. Then we were told that in 2 years and 8 months, which means that in 24 plus 8 equals 32 months, that population started decreasing. But at that point, in 32 months, the population, if we apply 32 instead of t in the first logarithmic function, we should get that we had a population of 150 bunnies. When that population reached 150, then it was when the exponential function took over. So the logarithmic function for t equals 32 should be of the same value with the exponential function when t equals 0, which means that g of 0 should be equal to 150. By substituting these values, we get that 150 equals A plus 20, which means that A equals to 130, not bunnies. Excuse my mistake. A is just a number. E, calculate the value of R. Well, we were told that the population now decreases by 3%. This means we should know it by theory that R should be equal to 100 minus 3 over 100, which equals 97 over 100, which is equal to 0.97. Find the population of bunnies after another 2 years. Remember that we are using the exponential function. We have already found that A is equal to 130, that R is equal to 0.97, and we need the population after 2 years, which means that T is equal to 24. By plugging in all these values, we get that G of 24 is equal to 82.584, but we're talking about not about objects, not about time, we are talking about live beings. So we should always round down. Hence, we would have 82 bunnies. Will there ever be a time where the bunnies will extinct from the campus? Justify your answer. By looking into the exponential function of g equals 130 times 0.97 to the power of t plus 20, we know that this has a horizontal asymptote of y equals 20. This means that as t gets bigger and bigger and bigger, the population should reach number 20. Hence, there will always be at least 2 bunnies in the campus, 20 bunnies in the campus. Therefore, they will never extinct. Let's move to exercise 3. The following graph represents a function g of x after a reflection on the x-axis and the vertical dilation by a factor of 1 over 2 to an original function f of x. A, show, not shot, let me show that the formula of g of x is g of x equals negative 2x plus 4. So basically, we were told to find the equation of this blue line in front of us. We clearly see that we can know 2 of its points, which are the intercepts, the points with coordinates 2, 0, and 0, 4. The equation we're looking for should be written in the slope-intercept form y equals mx plus c. The slope is given by the formula y2 minus y1 over x2 minus x1, which is equal to negative 2. And the y-intercept is 4. So by substituting all this information, we get that g of x is actually equal to minus 2x plus 4. Find the formula of f of x. Okay, we originally had the f of x. Then a reflection on the x-axis occurred, which means that from f of x, we went to minus f of x. And then on that, we applied the vertical dilation by a factor of 1/2. So we multiplied that by 1/2. So in the end, we got minus 1/2 times f of x. But that was equal to g of x. So minus 1/2 f of x equals to minus 2x plus 4. We multiply by minus 1 to get rid of the negative sign. So 1/2 f of x equals 2x minus 4. And we multiply again by 2 this time to lose the fraction. And this ends in the notation of f of x, which is equal to 4x minus 8. Exercise 4. Let f of x equals 2 times 3 to the power of x minus 4 minus 18, and g of x equals log 4 of x plus 16. Given that A is the x-intercept of f, B is the point at where the horizontal asymptote of f cuts the y-axis, C is the y-intercept of g, and D is the point at where the vertical asymptote of g cuts the x-axis, find the midpoint M of segment AC and the distance between points B and D. So basically, we just need to find the coordinates of points A, B, C, and D respectively. Let's take them one by one. A is the x-intercept of f. So what should we do to find the x-intercept of a function? We should go to that function, put y equals 0, and solve for x. By doing that, we get that 0 equals to 2 times 3 to the power of x minus 4 minus 18. Thus, 18 is equal to 2 times 3 to the power of x minus 4. Therefore, 9 is equal to 3 to the power of x minus 4, which means that 3 squared equals 3 to the power of x minus 4, which means that 2 is equal to x minus 4. So finally, x is equal to 6. And hence, the coordinates of A are 6, 0. B is the point at where the horizontal asymptote of f cuts the y-axis. The horizontal asymptote of f is of the form y equals minus 18. Look at the graph I have drew. The y equals negative 18 cuts the y-axis at the point B. That point obviously has coordinates 0, negative 18. Moving on, C is the y-intercept of G. Like the x-intercept, this time in order to find it, we should go to G, put x equals 0, and solve for y. By doing that, we get that y is equal to log base 4 of 16, which equals 2. So C has coordinates of 0 and 2. And finally, the vertical asymptote, we've seen that earlier. To find the vertical asymptote of a logarithmic function, we should take the argument x plus 16 in this case and make it equal to 0. So x should be equal to minus 16. That vertical line, the x equals negative 16, cuts the x axis at the point with coordinates negative 16, 0. So overall, the points A, B, C, and D are the ones with coordinates 6, 0, 0, negative 18, 0, 2, and negative 16, 0. The midpoint of AC, given the midpoint formula, which is actually in the booklet, the midpoint of AC should be 6 plus 0 over 2, 0 plus 2 over 2, which is equal to 3, 1. Regarding the distance, once again, the distance formula is provided in the booklet. We only need to apply it correctly. So the distance should be square root of 0 minus minus 16, that's why it became plus minus 18 minus 0. After some easy calculations, which after all are done by the GDC, we end up at 24.08 and so on. Let's move to the final question. Let the points A with coordinates 3 and 6 and B with coordinates 10 and negative 2. Find the coordinates of point C. Let's put a note here. If you know that it is placed on the segment AB and AC is equal to 1/7 times AB. Here, I have drawn a set of axes and I have plotted points A and B. C should be in a distance so that AC is equal to 1/7 of the entire AB. What I did next is that I formed two right triangles. The triangle AOC, which is this small one here, and the bigger one, AKB. The vertical distance from A to K is 8. The vertical distance from K to B is 7. The small triangle and the big triangle should be similar because they are both right and all their angles are congruent. Since AC is equal to 1/7 of AB, the same proportion should stand for all corresponding sides of these triangles, which means that AO should be 1/7 of AK, so AO should be 1/7 of 8, and OC should be 1/7 of KB, so 1/7 of 7. This means that in order to go from point A to point C, I should go 1 unit to the right and 8/7 units downwards. Hence, by starting from the coordinates of A, which are 3 and 6, I will add 1 to its x coordinate and take out 8/7 to its y coordinate respectively. And that will lead me to coordinates 4 and 34/7, which are the coordinates of point C. And that will be all. I hope you liked the test. And as always, thank you for your patience and time.